Take a look at this. Do you have any idea what's going on here? If your answer is, maybe, you are not alone. And yes, I know what you are thinking. Why not just ask ChatGPT or any AI assistant to explain it? Sure, that works. But what about job interviews? When they hand you a real-world regex problem and say, can you tell me what this does? You won't have AI whispering the answer in your ear. Regex looks scary at first glance, almost like someone smashed their keyboard in frustration. But once you actually understand the patterns behind it, this crazy-looking thing becomes one of the most powerful tools you will ever use as a developer. And that's exactly what we are doing today. I'm going to break regex down in a way that's super clear, super practical, and by the end of this video, you will look at patterns like this and say, oh, that's easy. Alright, let's jump. Regular expressions are often shortened to regexp or regex. People pronounce them differently, but the meaning is the same. If you are watching this video on YouTube, you will notice a poll on the top right. You can vote there to tell us which pronunciation feels more natural to you. But no matter how you say it, a regular expression is basically a tool that helps you find a specific pattern within a string or text. It has two common use cases. First, it's useful for validating user input. Second, it plays an important role when searching through large amounts of text. For example, it's very handy when performing find and replace operations in a big document. Many programmers are intimidated by regular expressions. Just looking at the syntax can seem overwhelming, but once you learn it properly, parsing text in any programming language becomes much easier. In short, regular expressions are a universal and extremely powerful way to parse text. For example, in JavaScript, you can use match to find all matching patterns within a string. With search, you can check if there's a single match. And using replace, you can replace that matching pattern with something else. But before doing any of this, it's important to know how to write a regular expression. Let's quickly go through that. There's a really handy and simple website for working with regular expressions and testing them live, regexr.com. I will put the link in the video description. Right now, I'm on that website. You'll see two main sections here. One is where you write the regular expression, called the expression section. The other contains the text where we will look for matches. As we write the expression, we can see live which parts match. Let's get started. The very first thing to understand about regular expressions is that in JavaScript, you start by adding two forward slashes. Whatever we write between these two slashes will be treated by JavaScript as a regular expression. Let me show a simple example, the easiest one. Suppose we want to check if the word color exists in our text. I just wrote color and you can see it matches immediately. That's because we gave an exact match here, but the word color appears in a few other places in the text too. For example, color. Yes, like this, or after hex here, color. These also get matched. By default, a regular expression only returns the first match. But if we want all instances of color to match, we need to turn on a flag called global. Notice how we turn on the flag. There's a flag section here. As soon as I enable G from here, a G appears after the last forward slash. There are other types of flags too. For example, there's a case-insensitive flag, which helps match letters regardless of uppercase or lowercase. Suppose the first C in color here is lowercase, and after you are not, the C in color is uppercase. By default, these didn't match because the regular expression is doing an exact match. If we want it to match regardless of uppercase or lowercase letters, we need to turn on the I flag after G. This is the case-insensitive flag. See, we have written I after G. There are many other types of flags too. Basically, we write the flags after the final forward slash and they change how the match behaves. For example, now I have written color with the flags G and I. This means it will match color exactly, but it won't be case sensitive. And G means it will show all matches. So all instances of color are matched and shown in a case insensitive way. This is the very basic idea of regular expressions. So far, we have only looked at exact matches. But actually, inside the forward slashes, you can write not just exact strings, but any expression or pattern. And these are also accepted. So, what do you mean by an expression in JavaScript or any other programming language? Just like we use AND operator, logical OR operator, or other types of expressions, we can also write expressions inside the forward slashes. For example, suppose we want to match two variations of the word color. One is COLOR and the other is COLOUR. Now, if we want to match both, we can use a logical OR. In JavaScript, the vertical bar is used for OR. See, now COLOR and COLUR also matches, and it works in a case-insensitive way. This shows we can use the logical OR operator here. Next, what we will learn is that we can group expressions if needed. For example, we can use brackets to group an expression. Just like in calculations or operations, we can use the first bracket to set priority. Whatever is in the first bracket gets processed first, then the next. So we can use grouping, right? We can even do grouping inside the forward slashes. Suppose we want to match the phrase colorblind. Earlier, we used the expression /color or COLOUR/GI. Now, if we put the whole expression inside brackets, it will be treated as a group. What does this group do? First, the work inside the group happens. That is, it matches either color or COLOUR. Then, I want a space and the word blind to match after the group. See, when we write COLOR or COLOUR in the bracket, then space blind, first the group matches color or COLOUR, then the space, and finally blind matches. This way, we can group any complex expression and have different parts work separately. Another amazing feature of regular expressions is character classes. By using character classes, we don't always have to rely on exact matches. For example, we might not want to match the word COLOR directly. Suppose we want to match any type of word character like M, Y, or any other letter from A to Z. Using character classes, we can select any word character in this way. We use /, then a lowercase w. You will see that it selects all word characters, but it doesn't select spaces in between. New lines, tabs, or hashtags aren't selected either. In other words, it only picks word characters, like the letters used in English words. This is what /w does. We can also use / a lowercase d, which selects digits. See, for example, in 808080, all the digits are selected. Very simple, right? Next, we can use /s. Here, you will notice it doesn't just pick normal spaces, it also selects tabs, since a tab is basically a combination of spaces. However, new lines like /n aren't selected here. So, we have seen three character classes, /w, /d, and /s, all lowercase. Now, if we use uppercase letters, we get the opposite behavior. For example, uppercase /w will select everything except word characters. Similarly, /D will select everything except numbers, but it won't include new lines. Spaces, tabs, and so on are included. Also, if we use uppercase /s, it will select everything except white space. Along with character classes, we can use /t to select just tabs. If we specifically want to select new lines, we use /n. You will notice it doesn't show anything directly in the text, but here it shows 4 matches, meaning 4 new lines have been selected. Another character class is the dot. Dot means any character except a new line. That includes numbers, word characters, spaces, symbols, everything except a new line. Dot is also called a period. Using these character classes, instead of matching something specific, we can abstractly select a type of character, number, or space. This makes it easy to identify any specific type of element in a regular expression. Next, we'll look at another important feature of regular expressions, the use of third brackets or square brackets. These are also called brackets. For example, if we write square bracket ABC, it means A, B, or C. Any one of these characters will match. Notice that if the case-insensitive flag is on, uppercase letters will match too. That means uppercase ABC within the third brackets won't just select lowercase ABC. It will also select the uppercase versions. Simply put, anything inside the square brackets can match any one character. Match any A, B, or C. This is a basic and simple concept of regular expressions. So, it will select A if it appears, B if it appears, or C if it appears. Each character inside the square brackets is considered individually. Now, we can also use a range inside the square brackets. Suppose we want to select all characters from A to Z. Are we going to write A, B, C, and up to Z one by one? That won't be practical. So, we can use a range like A to Z within square bracket. This means it will select all lowercase characters from A to Z. Earlier, I turned off this case insensitive flag to make it easier to understand. See, if we limit it from A to Z, only the characters within A to Z will be selected. Another example is if you want to select lowercase a to z and uppercase a to z, you can write this as two separate blocks inside the square brackets. The rule is whether you specify range or individual characters inside square brackets, each one is considered separately. That means first it will match anything from small a to small z. Then it will match anything from uppercase a to g. You can add more ranges if you want, like z to l and uppercase z to l. This way, any number of ranges or character blocks you specify will be considered individually. Regular expressions will take each one as a separate match. Another important feature is negation. You can reverse the function of the square brackets if you want. For example, within square bracket, A to C matches A, B, and C. But if you want to match everything outside that range, you can use a negation sign, that means the cap sign inside the square bracket A to C. Here, the cap sign means not or negate. For instance, within square bracket, cap sign small a to small z matches everything outside A to Z. This makes square brackets in regular expressions very powerful and flexible because they can handle specific groups or ranges in reverse as well. So far, we have only matched patterns, but we haven't defined how many times they should match. We have just given a pattern and selected wherever it appears in the text. Now, suppose you want to match characters from A to C, but you also want to control how many times they match. In other words, you want to define the quantity. This is possible in regular expressions. For example, take the word color. Sometimes it's spelled with a U, sometimes without. We want to match it while also controlling whether the U appears or not. We will also turn on the case insensitive flag because there are uppercase letters too. Suppose someone wrote COLOR as capital COLOR and someone else wrote COLOUR as capital COLOUR. Now, if you have a large text document where both versions appear, we want to match them all. Here, the U is optional. That means it may or may not be there, 0 or 1 time. In regular expressions, we use the question mark to indicate this. The character right before the question mark, in this case, U, can appear 0 or 1 time. So U means the U may or may not appear. Whenever we do this with the I flag on, the regular expression will select both COLOUR and COLOR. This is how we handle 0 or 1 occurrence. Now, suppose a character like R is repeated 2 or more times in one places. If we want to select 0 or multiple occurrences, we use a star after the character. Here, the star means 0 or multiple occurrences. That is, R may not appear, may appear once, or may appear multiple times. So, a regular expression like COLOUR then star covers all situations, whether R appears multiple times or not at all. On the other hand, if we use a plus instead of the star, it means one or multiple occurrences. That is, it cannot be 0. It must appear at least once or more. For example, COLOR, then a plus sign ensures that R appears at least once or multiple times. So, COLO alone won't match. This is quantification. What we have learned is question mark means 0 or 1 occurrence, star means 0 or multiple occurrences, and plus means 1 or multiple occurrences. These quantifiers are easy to remember with a little practice. There aren't many, just 4 or 5 basic rules, but it's important to practice them to recognize and understand them, which is why I am helping you here. So far, we have only talked about 1 or multiple occurrences. But if you want more specific control, meaning you want a character to repeat an exact number of times, you use braces. For example, if you want the letter R to repeat exactly twice, you use 2 within braces. Then R within braces 2 will match R exactly 2 times. If it appears only once, it won't match. You can also specify a range like within braces 1, 3, which means the repetition will occur a minimum of once and a maximum of 3 times. Exactly, since we have given within braces 1, 3, everything within the minimum 1 and maximum 3 repetitions will match. So here, R repeated twice matches, while COLO doesn't match because it doesn't meet the minimum 1 time condition. We can specify exactly how many occurrences we want, 0 or multiple, 1 or multiple, or 0 or 1. Similarly, using braces, we can precisely state how many repetitions we want. We can even give a range, allowing us to quantify exactly. This is why with regular expressions, we gain full control over every part of a string. This is what quantification in regular expression is all about. Now, here's something many people get confused about. In regular expressions, there are several special characters that are reserved or act as key characters. For example, notice when you use a question mark, the regular expression highlights it in blue. That means it's recognized as a keyword or key character by the regular expression engine. In other words, the engine understands that this symbol has a special function, not just plain text. Now, if your text actually contains a question mark or any other key character, you want to match it literally, you can't just use it directly. That's because the regular expression engine will interpret that character according to its special meaning. In text, a question mark has a normal meaning. As a string, we want it as is, but in a regular expression, it's treated as part of an expression. So, if your text has such a case and you want the regular expression to treat it as a literal string, you need to escape it. To escape, for example, suppose your text contains COLORS and you wrote /COLOU, a question mark, RS, and then ending slash. Now, if you want the question mark to be selected literally, using it directly won't work because the engine interprets it with its special meaning. You need to put a backslash before it, like backslash then the question mark. When you escape it, the regular expression understands that you want it to be considered as a literal string with no special meaning. Only then will it match correctly. This is a very important point and many people get confused about it. Any character in a regular expression that has a special meaning must be escaped if you want to match it literally. This way, the engine treats it as a plain string with no special function. Now, let's talk about anchors in regular expressions. Anchors are used when you want to match the start or end position of a string. It's very simple. You have already seen the caret symbol. It works as an anchor and denotes the start of a string. If you want to check whether a string starts with my, using the caret will match it exactly. For example, if the string starts with my, the regular expression recognizes it as the start position and shows a match. Suppose my text ends with hey hey and an exclamatory sign and you want to match the end position. You would write the expression as hey hey, then the exclamatory sign and then $. The $ sign at the end indicates the end. The regular expression then understands that the text ends with hey hey and the exclamation sign and matches accordingly. If you want to match both the start and end positions, you can use anchors for that. For example, suppose you want a line to match only if it starts with a number. You would use the caret at the beginning and then specify a number range like 0 to 9. As I mentioned earlier, we can use square brackets to define ranges. Now, if the string doesn't start with a number, it won't match. Similarly, if your text started with 10, the first position would match. Or if you want any line that starts with a specific word to match, it will match if the text begins with that word. This is how we use the caret for the start position and $sign for the end position. For example, if the text ends with an exclamation mark, the $sign will match that end position. This is one use of anchors. Another important point about anchors is when we turn on the multi-line flag in the flag section. The aim flag comes into play here. This means matches will now occur line by line instead of looking at the entire string. Previously, we were checking the start and end of the whole string, but now it checks the start and end of each line individually. For instance, if you use a $sign to match an exclamation mark, you'll see that it matches both the line with blind and the last line. That's because it's working in multi-line mode. Similarly, for the start position with a caret, if we use I, both lines are now selected. So, to define the start and end positions for multi-line text, we need to turn on the aim flag. In JavaScript, there are mainly 4 functions to work with regular expressions. One is match, another is search, then replace, and finally test. The match function checks the text against the regex, and if there are matches, it returns all of them as an array. The search function returns the position of a match, that is, the index in that array. Using replace, we can change the part of the text that matches the regex to anything we want. The test function checks whether the regex matches the text or not and returns true or false. Now, let's see an example. Suppose in HTML we use color codes, meaning hex color codes, like #2a2a2a. We want to match this color code using regex. Here, first there is a hash symbol. We want it to be optional, so the user may include it or not. Then comes the pattern for the color code itself. Hex color codes are written in pairs. Each pair can be 2 numbers or 2 letters. The letters can be A to F, either lowercase or uppercase, and the numbers can be 0 to 9. The rule is that each pair must contain exactly 2 characters, no more, no less. We can match all these rules using a regular expression. So, if we create a regular expression for a hex color code, we start with 2 forward slashes and turn on the G flag. First comes the hash symbol. We want it to be optional, so we use the question mark as a quantifier. This means the hash may or may not be there, and if it is, it appears once. Next come the pairs of the color code. For each pair, we create a group. For example, the first pair might be 2A. In this group, there can be a number or a letter. So, we use square brackets to define the range. Numbers 0 to 9 and letters A to F or capital A to capital F. Then, we use a quantifier to specify exactly 2 characters per pair. We create this group and then repeat it for the other pairs. So, the entire hex color code pattern should match. Now, we test it. When you call the replace function, if there's a match, it will be replaced with hash and 6 zeros. First, we check the matches result. Here, we get a match returned as an array, and the index shows that the element is at position 0. Then, using the replace function, we see that the value has been replaced. For the test function, we get true, meaning the pattern matched. This means our regular expression is working correctly. This is our first example. Now, let's look at a second example. Here, we will validate Bangladeshi phone numbers. Suppose the number starts with a plus and 88, but the hyphen may or may not be included. This part will be optional. Then comes 0, 1, 9, followed by a series of 2 digits, and the total length should be 11 digits. For example, after 0, 1, 9, the next digit can be any number from 1 to 8. We want to validate this format using a regular expression. So, when a user enters a phone number in a form, this regex will help check whether it matches the Bangladeshi phone number format. First, we said that plus 88 should be optional, meaning the user may or may not include it because it's the country code. But if we write plus 88 directly, it won't work. According to the quantifier rules, only the item immediately before the quantifier is considered optional. So, if we use question mark directly after the first 8, only that 8 becomes optional, not the whole plus 88. To make the entire part optional, we need to group it. By creating a group, the regex understands that the whole segment is optional. Another point, the plus sign is a special character in regex. So, writing it directly would give a different meaning. We need to escape it. So, the regex treats it as a literal plus sign, not as a keyword. That covers the first condition. Next comes plus 88, which is fine. Then the hyphen, which we also keep optional. After that, the start of the Bangladeshi phone number. For example, 01, which must be present. The next digit can be any number from 1 to 9. So, we can't use /t here. Instead, we use square brackets 1 to 9 to specify this range. In this way, 01 and the following number are correctly covered. Next comes the remaining 8 digits, just 8 numbers. For this part, we use /d and specify it to repeat exactly 8 times. Now, this segment is fully covered. Let's test it. Unlike the hex color example, here we can just replace it with something simple, like phone. You can see the phone number matches, appears at index 0, gets replaced with phone, and the test function returns true. Even if the user doesn't include the plus 88, it still works perfectly. And if the plus 88 is included, but the hyphen is missing, it still matches. So, the pattern we wanted works exactly as intended. I have shown you 2 regular expression examples and also demonstrated the thinking process behind creating them. Hopefully, this tutorial gives you enough resources to practice.
Regular expressions may seem intimidating to many, but remember, it's not rocket science. It's simply about syntax. There are a few key syntax rules, and with practice, you can master them. And if you ever get stuck, Google search is always there to help. You can easily find perfect, large, and complex regular expressions on Google. But if you need something custom, it's important to first understand whatever you find. That understanding lets you break your string into parts and create regular expressions for each part according to your use cases. As I have shown, using just some basic regex syntax, you can cover most types of regular expressions. Personally, I have never had to go beyond these basics. I hope after watching today's video, your fear of regular expressions has disappeared, and with a little practice, you will be able to use them easily. If you enjoyed this video, don't forget to hit the like button, drop a comment to let me know your thoughts, and share it with your friends so they can get benefited too. Most of the people who watch my video aren't subscribed yet. So if you want more content like this, make sure to subscribe to the channel. It really helps me bring you most value-packed tutorials. And before I sign off, let me quickly mention our Logic Based Labs Facebook page. That's where we regularly share coding cheat sheets, design system guidelines, and tons of developer-focused content. If you want this kind of rich, practical value in your feed, go follow the page. You will find all the links, GitHub, Facebook, everything right there in the video description. Thanks for watching, and I will see you in the next lesson.